Well, here we are in the garden of Scar Cottage in Martley, where we have these splendid exposures of Triassic sandstones, what used to be called the Bromsgrove Sandstone Formation, now the Helsby Sandstone Formation. And this is a really nice stone for making blocks that can be used for building purposes. It breaks in a very nice, clean, even way, and so it was clearly prized, and already by the first Ordnance Survey maps in the 1880s the quarrying was complete. We've got this very nice face here, decorated with these grooves created by quarrymen when excavating out blocks, and that carries all the way along here. But we see over here what's happening is that layers are broken off, and we've got into this smooth material which is behind the original quarried face. So one thing that will happen once you've excavated blocks out is that there's a great relief of pressure on this vertical surface. It's under tension, and that means you'll tend to form cracks parallel to that surface. It's a bit like, you know, the granite tors in southwest England, which have got horizontal cracks, and that's because the overlying area has been eroded away, and then there's release of pressure, and then you get those cracks in that direction. And so here it's in a vertical direction. And that may also then be assisted by water coming in and maybe drying out and forming salts locally, which would tend to accentuate that. So we've got this sort of scaly surface here, and Ian's also mentioned the powerful erosive effect of his daughter playing football against the face. And then the other very, very powerful erosive agent is what? Frost. Frost is a powerful erosive agent, but an even more powerful and localized agent is what? Bees. Bees have their place, but think of something much slower and apparently harmless.
Rain.
Trees. So the power of trees' root systems to displace and erode rock is enormous. So we can see there's a whole area of rock here that's come away because of the effects that tree has had. And so it's gone right into the solid rock. It's not just in soil, it's actually going into the rock itself. So we've got all kinds of agents of erosion there. And then Ian talks about the wind whipping around here, and you know, he notices this and he thinks that this is helping to enlarge small cavities into larger cavities on this on this face here. So certainly if there was some water spray in there as well, I can imagine that could be quite important. And certainly there are lots of faces where bees can bore into rock. Have you got bees here? Any solitary bees doing that, Ian?
Lots, yeah.
You do?
Yeah.
So they're almost certainly got an agency here as well. So that's all to do with the rock as it is now. But there are some other things that we can say about the rock earlier in its history. In this part of the outcrop we can see that there's a very thick uniform bed here, what we call a structureless or massive bed, and it's quite hard to see how this sand accumulated. We don't see individual layers, but anyway, it's built up to this level, and above this we see a sandstone which is much more fissile. It's breaking much more easily along the bedding, and that bedding is not in a consistent orientation. There are some layers that are incline more steeply than others. So it looks as though there is some cross-bedding here. It's not at a very high angle, suggesting that there were some bed forms, maybe some small dunes in the riverbed, and that these were migrating and causing the sand to accrete in this way. So we're seeing a record of lots and lots of small depositional and erosional events in this upper part of the face. And this contrast between the lower and upper part is quite a useful marker horizon, and now we'll see what happens if we try and trace this along the face. So here we see again this massive or structureless sandstone, here about 2.5 meters high, and then above this more thinly layered sandstone. That forms a distinct bed there. But as we go this way, we see a distinct change. We've got this structure that runs up the face here, and when we look for that boundary between the massive sandstone and the more fissile sandstone, we have to find it rather further up the face there. So it looks as though this structure that's coming down the face is a fault, a normal fault, that is, it's got a down throw towards the right there. And it's a zone, it's rather than being a single surface, it's a zone of small fractures, and in the modern outcrop, of course, the rock is actually unstable in this wedge-like zone, and blocks are falling down from it. This strange cross-like structure here represents a zone where the sand is cemented by calcium carbonate, and it's harder as a result. And that sort of phenomenon can occur in different ways and at different times after the deposition of the sediment. Now there is a place along here to the left where we've got some calcareous concretions of this sort, which seem to have formed fairly early after deposition. And that is here. Right, so if you get your cameras out and zoom in, that's the best way, substitute for binoculars. And Ian has advised me to stay on the grass. I'm staying on the grass. But over here, can you see there's some little white patches, little blebs, white blebs in there? Now those are the sort of size and shape that I would expect for roots that have been calcified. So in an area with relatively low rainfall and strong summer evaporation, calcium carbonate precipitates in soils, and it can precipitate around rootlets to give you like little tubes. And I think that's probably what's happening in here. They're quite small, they're quite delicate, and they form in a zone that's parallel to the layering, which could be a surface that was actually exposed. There's another example which I think is more convincing in the road cutting. Over there though, we had something that was much bigger and which went down a considerable distance. So that I think is something that must have formed a lot later, because it doesn't obviously relate to the conditions of original sedimentation. It may be that is forming in a zone around another fault. There's a little bit of movement, opening a crack along which water can flow and bring in fluids that from which the calcium carbonate deposits. And it comes up the crack and then it spreads out along a layer that is a little bit more permeable, a little bit more easier for water to pass along to form the horizontal zone of the cross shape. So that's quite a large scale feature, whereas these are much smaller scale and much more sort of delicate looking features. And here we've got a roadside section on the B4204 outside Scar Cottage of these Triassic sandstones of the Helsby Formation. As we'll see in a moment, there are some quite coarse-grained gravelly layers and more massive uniform finer sandstones. Here we've got a pebbly sandstone unit that is clearly channeled at its base, and we can follow it along, and then it channels down again over here and the gravelly fill of this erosion surface is cross-bedded here. So there's a bed form, either a dune or a flat top bar, that is migrating in this direction towards the east here. And then there's another erosion surface, and then a second bed form migrates along, forming another set of cross-bedding. So these units are really quite distinctive, showing the gravelly base of what looks to be a braided river. But a lot of the deposits in the river are actually more uniform, finer sand. And here we have another very distinct erosional surface overlain by gravel, and we can see various different types of rock amongst the pebbles in this layer.